Alright, this video is for it's basically for hockey player, but I may end up posting this for everybody to see at some point. I'm not running the system today, but I'm just demonstrating, let's turn it sideways, just demonstrating how the system works and how I've changed how I operate it since getting that piece of equipment right there. So, the plumbing remained the same. It's just the way I run the system now, learning my lesson on trying to brew it twice and the thermodynamics that have changed in this piece here. So now, let's just start from the beginning. Control panel's not on right now, but there is, just so you know, there's a switch here. So when I built the system, I tried to build it with one pump using gravity and 2 probes. I don't care about that. I don't need a probe on there. I've got a gauge on the front, and who cares what the temperature is in there? As long as it's a rolling boil, I don't need a probe in there. I think that's actually redundant. It's a waste of money. A probe here, not necessary. You can use a gauge. Reason being is, for one, you're going to check it anyway with a manual probe, with a manual temperature going through the top, because you're going to double check all your gauges anyway. So you're going to check the mash to make sure that that is reading accurate. But more importantly, on the recirculation, this is the top of the mash tun, and this is the probe that's measuring the mash. So if you go back to the front of my panel, if I select mash, now the PID controller and the elements in the pot are now controlled by this probe. The reason being is because there's going to be thermal loss coming through. So your brew water, your mash water, is going to come down to the bottom. It's going to come in here. I'm going to have the valve select. This is a 3-way valve. I'm going to have the valve select to recirculate. It's going to come down here. I'm going to have the valve selected to recirculate. And I'll have this wide open. So now this is coming through here, straight through the pump. Follow the line. And it goes to this inlet here. Well, that inlet is actually tied to the coil. So it runs through the coil and then out here. Comes out here and then into the top of the mash tun. So if, I must have got turned when I cleaned it, if the mash has to raise quite a bit. In other words, if I'm doing a step, or if I'm bringing the mash up to sparge out, I'm going to recirculate, and the water, mash water coming out of here, the sweet wort, is going to be, let's say I'm mashed in at 150 here, and then I want to raise it to 169, 170. So it's coming out of here at, let's say, 149. Goes through the pump. By the time it gets to here, it's probably 145. Now it's going to go through the coil, reheat, and if I'm stepping in the early stages of the step, I'm going to be coming out of here at probably 152, 153. So it would be forever to ramp up if I wasn't controlling the PID with this. So when I'm down, now the elements are going to come on harder. They're going to come on and bring this bath water, basically the water surrounding the coil, up to temperature, so that when the sweet wort goes through the coil, it's picking up that heat quicker and it's raising the temperature quicker. And as it starts to get closer to the desired set temp in here, then it'll start turning the elements down. Now, what's going to happen is, and this is the part that you have to play with a little bit with your settings is that this water is now going to be well above the 170. It's going to be probably near 200 degree water in here. So if you've set your ramp time up correctly, this should start turning down the elements, and the constant recirculation, i.e. the cooling, thermal cooling going through here and going through the bath water, will actually drop the bath water down, and they will begin to converge. This temperature, and this temperature will all begin to converge together. Now, hockey player wants to take this probe and place it here. I think that's a bad idea, because you're not getting the temperature of what's coming out of here. You're getting the temperature of what's coming out of the bottom of this. So you're going to be chasing your convergence all the time. And I think you'll never be able to get this to converge with this. You're always going to be overshooting by a long shot if you're pulling your probe temperature off the bottom. That's just my 2 cents on that. All right, so let's start from the beginning now. Water comes into the filter. I have a 3-way valve here. 3-way valve is set for have the bottom of the HLT drain straight through like this into the pump. So in the fill mode, if I want to fill the mash tun, I fill the mash tun from, if I want to fill the HLT, I fill it from the bottom. So I would select this to fill. Now this brings the tap water in and bottom fills the HLT. And then, as you can see, that's just a straight shot in at the bottom. So that bottom fills the HLT. When it's full, you'll see it on the sight glass, I shut it off. Shutting that water off actually shuts off this part, but actually connects this part into the pump. So when I'm not recirculating, when I'm filling or fly sparging, I do this. This 3-way valve now takes the inlet and it goes straight through the coil and out through the top. So that's the fill mode. So now I'm full, I'm raising the temperature. Let's say my temperature for my mash is 152. I'm going to get this to, let's say, 170, because there's going to be some thermal cooling going into here. I need to raise the temperature of this. So I'll set it to, let's say, 170. I'll shut the elements off. I will fill this up. I will look at the gauge in the front. If I'm close and I feel I can mash in and get to mash temp, I will do that. If I can't, I still go back and fill this back up, turn the elements on. Now I set my temperature to my mass temp, whatever it is. Let's say it's 152, like I said. I set it to 152. I put it to mash, and then I start recirculating just the water. That's the change that I've made. So I would select this to this, and I would just recirculate the water through the pump, through the discolored hose, through the coil in the bath water, out through the top, being sensed by that probe, in through the mash tun, and then I should see this temperature get to my desired temp. Now, Beersmith will calculate for me, let's say the grains are at 80 degrees. If I'm adding so many pounds of grains, it's going to tell me what I need to have this temperature at, so that when I add the grains, I'm at my target temp, 152. Before, what I was doing was trying to guesstimate how hot I needed this to thermally change this and just add the grains. Now, this being metal and not a cooler and larger, and the temperature changes throughout the year. In the summer it's 80, in the winter it's 30 degrees outside sometimes, and I'm brewing. I was always chasing that number. So now I'm not doing that anymore. Now I am actually recirculating just the hot water until I reach the desired temperature here before I add the grains. That is the biggest change that I've made in my process. Plumbing has remained the same. All right, hockey player, I hope that, I don't know, I think you mentioned something about a third probe, and I don't really see where you would need that unless you're going all electric. And if you're going all electric, you really don't need a probe there, because you're going to set the PID. You're going to get a different PID. You're going to set it for a pulse width modulation. So you're either going to have it at 50%, at 30%, or 100%. So you'll have it at the PID at 100% when it's bringing to a boil, and then you'll knock down the percentage, which basically changes the pulse width of your on-off cycle of the elements, and that's what controls your boil. Don't need a probe for that. So again, it's like looking at the gas. Oh, the gas is too high, you turn it down. Oh, the boil is too high on the electric probe, I turn the percentage down. That's why I think a probe in there is a waste of money. Okay, hope that clears it up. If you have any questions, let me know. If I do post this on the internet for everybody to see, if you have any questions, let me know. Cheers.